All right, welcome to the review sheet. Just going to go through this and then hopefully you guys can watch the video. So if you have any questions, this will help you out. We're going to take a look and go through the matching and then some questions, and then we'll do the proofs at the bottom here. So, all right, let's start with the first one. So we're going to go through and do our matching. So let's look at the alternate interior angles. Remember, that makes the Z here. So we're looking for the Z. And there's the Z down here with letter G. So you can see the Z for the alternate interior angles. Terrible looking Z, but you get the idea here. All right, so let's try that again. Z, better. All right, those are alternate interior angles, so we know that number one is G. Okay, corresponding angles are in the same position, so these are almost like this, but this would have to be up here more. These are not, oh, those are them. So you can see this one's top right here and top right here on the intersections. So D is going to be our corresponding angles. Alternate exterior angles, so this should be on opposite sides and then both outside the line. So this should be on the exterior, and here we are. Opposite sides, both outside the line. So these are our alternate exterior, so that's an I. All right, complementary angles add to 90. So these two angles you can see right here form a 90-degree angle. Nice and easy. Vertical angles are where the two lines cross. The opposite angles formed here, so these two angles are vertical. So that's C. Supplementary angles are angles that add to 180. They don't necessarily have to touch, but they can. They could also be drawn something like this to be supplementary angles. So this is also a linear pair. And so B would be the appropriate choice here. Linear pair, like we said, we're talking about the ones that form a straight line. That would be these two right here. You can see how these form a straight line. Same side interior, just like it says, they're on the interior and on the same side, both on the left or both on the right. And that would be number one, or letter A there. And then adjacent angles would be H. Two angles that are next to each other, that would be the most appropriate answer for that one. All right. Technically, these angles are also adjacent, and so are, nope, just these two, but these are complementary. That's the one that best fits that one, so we'd want to choose H there. Okay. Diagram below. So I can see the lines are parallel, and we have a 90-degree angle being formed when QR and ST meets. Remember, this upside down T symbol means perpendicular. Okay, so we get a 90-degree angle there. All right, so there's our 90-degree angle. Now remember, when the lines are parallel, our favorite letter to look for is the Z. So I can see that these two angles are equal. Okay, so if one is equal to 63, then this angle is also equal to 63, and I'm looking for the measure of angle 2, which is part of this triangle. So I know the angles of a triangle should all add to 180, so that's going to be how we're going to do this one. So 180 minus the sum of 90 and 63. All right, so we know 90 plus 63 is 153, so 180 minus 153, oops, 53 is, and that's the measure of angle 2. Okay, so 27 degrees for number 10. Number 11, we have the angles, and we want to pay attention. T, V, Q, so it starts at T, goes down to V and over to Q. So that's the angle here located at V. And then VWS would be from here over to here. So these two angles are corresponding. And if you remember, the corresponding angles are congruent. So we know that these two measures are equal. So we want to do 5x minus 22 equals 3x plus 10. We're going to move the x's on the same side first. So this is 2x, and then minus 22. Why does that whole thing go away? All right. Switch to the eraser here. So 2x minus 22 is equal to 10. So we'll add the 22 over to the other side. So we want to get the x's on one side, the numbers on the other. Undo the addition subtraction first. And then divide out by 2. And x is going to equal 16. So we want choice 2 for that one. All right. Perfect. Okay, number 12, in the diagram to the right, we know that AC, which is this entire line segment, is congruent to BD, which is this entire line segment. Which of this information could be proven? So, you can kind of see when we look at this, that this segment, right, is actually made up of B, C, and CD, and this is made up of A, B, and BC. So, the thing that's the same here is this segment BC. And so if we were to think about this segment, right, as really AB plus BC, and this segment is actually BC plus CD, then if we made this equation, we would be able to subtract the BCs from both sides, right? Since those are the same, so you can kind of cancel those out. And I would get left with AB. Wrote the wrong thing there. Yeah, I want the eraser here, please. Okay. We get left with AB equals CD. So this would be the thing we'd be able to prove. Okay, we wouldn't be able to show that BC is equal to AB because we don't know how big this is compared to that. AD minus BC, so AD minus BC does not equal CD, it's equal to AB plus CD. And AB plus CD, right, does not equal AD because it's missing the middle piece, so that wouldn't make sense either. And BC and AB being equal, we wouldn't know that unless we know that these are exactly like this is the midpoint of that, and that's the midpoint of that. It would be the only way that would make sense. Okay, number 13, we know angle L is 55. Angle NOM here is 28. We want to know what the measure of angle N is. Now, the other cool thing or key thing is that triangle LMO is isosceles. So if LMO is isosceles, then LO is equal to MO, and these two base angles are equal. Okay, so that means that this is also 55 degrees, and this angle and the angle next door have to add to 180 degrees. All right, so 180 minus 55 is going to equal 125. And now I can use my triangle here to figure out what angle N is. So 125 plus 28 is 153, okay? And then 180 minus 153. Hey, we did this before. That's 27 degrees. And that would be the measure of angle N. All right? Perfect, so good. Okay, let's do our proof here. So we're going to do our T-chart. Statements and reasons. Number 1 is always the given. So angle 1 and angle 2 are supplementary. Now remember, we need to make a new statement using that word. Okay? Angle 3 and angle 4 are supplementary. And the reason here is given. So the word supplementary means that they add to 180 degrees. So angle 1 plus angle 2 is going to equal angle 3 plus angle 4. And now remember, since we're using this equals, we should really be using that measure here. Okay? And the reason, oh, timeout. Nope, that's not what we want to do there. So because these are supplementary, that means they add to 180 degrees. Now we're going to use the m here because we're going to be adding to equal something. Okay. Remember, equals, we should put the m, and congruence, we should put without the m. And then the measure of angle 3 plus the measure of angle 4 is also equal to 180. And because we use the supplementary, we just want to define that. So supplementary angles add to 180 degrees. Perfect. Okay. Now, step 3, once we get these two equations to equal 180, I know that since they're equal to 180, they're equal to each other. So measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. And so that's the transitive property T-I-V-E here. And the other thing we could also write down besides transitive is, once again, substitution. Okay? Now, there's nothing that's the same. Like there's no 2 and 2 on both sides. So what we want to do is we go back to the picture over here. We want to see, is there anything that we can see is equal? And remember that if these two lines are crossing, and they're straight lines, that there's going to be these angles on opposite sides here, these vertical angles that are equal. So for step 4, we want to say that angle 2 is congruent to angle 3, and that's vertical angles are equal. And now we could subtract 2 from both, and we could cancel out the 2 and 3 since they're equal if we subtracted them to get the measure of angle 1 equals the measure of angle 4. And this is the subtraction property of equality. Okay? All right, same thing for 15 here. So go ahead and do our chi chart. Statements and reasons. First one's always going to be the given. So we want to say that we have ray ACD, that ray CE, CE bisects angle DCB, and we know that CE is parallel to AB, and that reason is given. Okay, so key vocab words from the given. We see bisects. So bisects means cut in half. So if I cut an angle in half, I should get angles. Just like if I cut an apple in half, I don't get oranges, I get the same type of thing, I get more apples back, okay? So if you cut an angle in half, you should get 2 angles that are equal. Now DCB is right here, okay? So if I cut this angle in half, I'm going to get these 2 equal parts on both sides. So we're going to know that angle 1 is congruent to angle 2. And the reason for that is a bisector, okay, cuts an angle into 2 congruent or equal parts. All right, now we're going to use this parallel part. We want to say that A is equal to B. And if you notice, when we look for our parallel lines, so we know that CE and AB are parallel, we have a Z here, okay? And we also know that this angle formed right here, where angle 1 is in the same position as angle A. So these two are going to be equal. These two are going to be equal. And then we can use our transitive property to make them equal to each other. Or really substitution, not transitive. Okay? So let's start with number 3 here. All right, so the next part we said, right, was we had these two angles. We have the z, and then we have these two angles going this way. Now remember, the z, right, makes alternate, A-L-T-E-R-N-A-T-E, alternate interior angles, okay? So that's what the z makes. So what we're going to say is we're going to say angle 2 is congruent to angle B, okay? We can say B because there's only one angle there. And this is that long, annoying reason. So 2 parallel lines cut by a transversal, the alternate interior angles are congruent. Okay, now we can't use the same reason for 1 and A because those aren't alternate interior. Those are in the same position, those are corresponding. So we need another reason to say angle 1 congruent to angle A. And so it's the same setup here. 2 parallel lines cut by a transversal, and then corresponding. All right, angles are congruent. Okay, so now we have 1 congruent to 2, 2 congruent to B, 1 congruent to A. So now we know all 4 of these angles have to be the same measure. So what we can now say is that angle A is congruent to angle B. And what we're doing is we're taking A, replacing it with 1, okay, and we're taking B, and replacing taking 2 and replacing B with it since it's equal. Okay, so 5 is just substitution. Not transitive, but substitution. Okay, and that's it, guys. So that's 15. Okay, so key things. We use the keywords in the given to create new statements. We use the picture to create new statements, right? If we see parallel, we're looking for the z. We're also looking to tie these together. And then we're looking to work backwards to say, if I want to show that these are congruent, I can get these two angles, okay, equal to each other, and then show that they're equal to A and B in substitution. And then for number 16, okay, we're doing a little algebra proof here in a way. So we know that in the diagram, this line and this line are equal, okay? Sorry, these two lines cross. These two angles are equal. So we know 4x minus 40 is equal to x plus 50. These are vertical. Angles are congruent. They are vertical and equal. And then we're going to solve for x. So we would normally, okay, take our 4x minus 40 equals x plus 50. We would subtract x from both sides to get 3x minus 40 equals 50. So we're not going to show the work here. We're just going to put down the next equation. So 3x minus 40 equals 50. And then we would add 40 both sides, okay, to get 3x is equal to 90. Oop, and then we actually need a number 5. We're going to divide both sides by 3 and get x is equal to 30. Now you could have done this in one step and then added the 40 to both sides here as well, and then just done this in one step and gone right from here to there to the 3x equals 90. So it just depends on how many steps it takes you to get to there. We'll take this extra step though. So 3x minus 40 equals 50, and this is the subtraction property of equality. Then I'm going to add that over to get 3x is equal to 90. And this is the addition property of equality. Okay, and then we get x is equal to 30 with the division property of equality. All right. So that would be our last algebra proof there. And that's it. And you could have gone, right, from this right into this and skip step 3. And it would still be addition or subtraction property equality and then division. Okay? So there is an option if you wanted to skip this step right here. All right? And then we would essentially skip this step. So we would just subtract x plus 40, divide by 3. That's what that would look like. All right? But we are going to leave that as is. Okay, that's it, guys. If you have any other questions, let me know. I'm going to post this video for you guys to take a look at. I hope you guys have a great rest of the day.